So if we, this is just a very quick, this is just a very quick overview on the unit circle. So the image here in front of us is the image that appears on the, or in the log tables rather. Okay, so you have cos, which is effectively the x-axis, sine, which is effectively the y-axis. Okay, and then the unit circle has a radius of 1 the whole way around, which gives us the points 1, 0, 0, 1, minus 1, 0, and 0, minus 1. Okay, as I go around the circle. If I want, I can convert them into degrees. So if I start here and this is 0 degrees, as I move up, this gives me 90 degrees, 180 degrees as I'm moving around the circle from 0 degrees, 270 degrees, and then finally 360 degrees is going to be the same as 0 degrees, effectively. Okay, so if I look at this line here, and I'm just going to go over it in red, okay, so this is of radius 1. Okay, so I can use sine and cos with respect to this triangle, okay, and with respect to, this entire right angle triangle, okay. If I say that cos is the x-axis, then this line here, okay, gives me some value of x. And this line here gives me some value of y, so that the point xy, or cos A sine A, okay, is some point on the circle. Okay, so in a minute I'm going to have a look at a point over here, okay, which is another cos, let's call it cos B sine B, which would be another angle. Okay, so just dealing with this first triangle here, okay, I know that sine of any angle is the opposite over the hypotenuse. Okay, so bearing in mind with this, given that the unit circle has a radius of 1, the opposite angle to A is y over 1. So sine A is equal to y, which is the y coordinate. Cos A is the adjacent over the hypotenuse. Okay, so the adjacent angle in the diagram is x over 1. So cos A is equal to x. Tan A, and this is new now, okay, while it was opposite over adjacent, okay, is actually more technically sine A over cosine A, okay, over cos A. So sine A from above is y, and cos A from above is x. Tan is y over x, okay, and we will see that with all of this as we go through it, okay. So, as I said, let's look at an angle over here now. Okay, so let me just rub off these lines. Okay, let me look at this angle here. Okay, so let's say it is 150 degrees. So from there to there, it is 150 degrees. Okay, so we've got cos 150, sine 150. Okay, because that's where the point on the circle goes from here. Okay, so always from 0, okay, all the way across to 150. Okay, and this is where we bring in now this idea of a reference angle. Okay, so if I drop that down there, okay, my reference angle, okay, let's just call this B for the minute. Okay, my reference angle B should always be to the horizontal. Okay, so I'm always taking a reference angle from the horizontal. Okay, and we'll see that in as we go through this. Okay, so cos 150 sine 150, okay, is actually the exact same as this angle B, okay, which is cos 30 sine 30. Okay, because if that's 150, okay, remembering now, if I get my highlighter, this line here is 180. Okay, and if I know that this is 150, then this one in here, this one in here has to be 30 degrees. Okay, so what we say is 30 degrees is the reference angle. Okay, and that's going to become very important as we go through the unit circle. Okay, if now I want to look at an angle of 225 degrees, let's say, okay, so 225 degrees is going to be down here somewhere. Okay, it's bigger than 180, it's smaller than 270. Okay, so from here all the way around to here is 225 degrees. Okay, remember that sine, cos and tan can't deal with any angles greater than 90. So I'm looking at a reference angle for the angle 225. All of this will come together as we get towards the end of this video. So the reference angle is in here. Remember what we said about the reference angle, that it's always taken to the horizontal. Okay, so the reference angle in here, if it's 225, I'm looking for whatever goes past 180. So 225 minus 180, because I know it gets to here, it's 180. So this additional bit from there to there is 45 degrees. Okay, so we have the reference angle for 225 is 45 degrees. Okay, now let's talk about the angle 300 degrees. So 300 degrees is going to be in here. Okay, so it's greater than 270, it's less than 360. So going from here, all the way around to there is 300 degrees. Sorry, I don't know what happened there. It's going from 0 degrees all the way around the circle to here, gets me 300 degrees. Now remember what we said, the reference angle, because I can only deal with angles from 0 to 90, the reference angle for this is here. Okay, so this is my reference angle for 300. Okay, so if it's 300 from here to here, okay, then from this point to 360 has to be 60 degrees. Okay, so if we kind of deal with this idea of a reference angle for a minute, okay, then the angle 30 degrees, if I'm looking at this triangle on the left, or this circle on the left, this angle of 30 degrees here, okay, is the same as this angle here. If I'm saying that I'm taking a reference angle, so this one is 30 degrees. Okay, so where I had, say, cos 30, sine 30 here, and I've said now that I have, if I go purple, cos 150, sine 150 has the same value as cos 30, sine 30. Okay, so how do I distinguish between them? Does that mean that everything, all of these, have the exact same value? Okay, well the answer is yes and no. Okay, it has to do with the signs on the unit circle. Okay, and these are quite important. Okay, we know that this is cos and this is sine, and we also know that tan is sine A over cos A. Okay, so if we look at all of these, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, so if I look at all of these and I say, right, well in the first one, cos goes from 1 to 0. So between 1 and 0, cos is always positive. Okay, and the x coordinates, if I looked at that as a coordinate grid, in the first quadrant would always be positive. Sine starts at 0 and it builds its way up to 1. So every number between 0 and 1 is also positive. And given that tan A is sine divided by cos, a positive divided by a positive is also a positive. So tan is positive. So in this one, they are all positive. Okay. In the second quadrant, cos now becomes negative because cos has gone the other side of the origin. Okay, cos goes from 0 to -1, and every number between 0 and -1 is negative. Sine remains positive because it's above the x-axis. Okay, so sine goes from the coordinate of 1 to 0. Okay, so between 1 and 0, sine is always positive. Tan, remember, is sine divided by cos. So tan in this case is plus divided by a minus, okay, which is a minus. Okay, so in this one, sine is the only positive. In the third quadrant, cos is still to the left of the origin, therefore cos is still negative. Okay, its coordinates would be negative. Sine is now negative because it is under the x-axis. Okay, and we know if we were to look at this as a coordinate grid and I was to plot a point in there, the x and the y would both be negative. Now remember, tan is sine, which is a negative, divided by cos, which is a negative, and a minus divided by a minus is a plus. So in this section, tan is positive. So tan is positive. Okay. In my final quadrant, in quadrant 4, cos now becomes positive. Okay, because it's now back to the right side of the origin. It starts at 0 and it comes up to 1. So every number between 0 and 1 is positive. Okay, sine, it's still below the x-axis, it's still negative, which means that tan is a minus divided by a plus, which is a minus. So cos is the only one positive in this section. There's a number of different ways that you can go about remembering them. One of my personal favourites is to read from left to right, and I have sex and the city. I don't know if you guys are old enough to remember that programme. There's other ones. Okay, there's also, if you want to read this way, you have cast. Okay, if you want to read it from there, C-A-S-T. I personally find that one a little bit trickier. Okay, given that we read from left to right. Okay, I'm a fan of the sex and the city approach. Okay, now what do these signs mean, or what's their relevance? Well, they actually have quite a big relevance, because if I go over here to cos 150, sine 150, okay, and I'm just going to rub off my blue lines here, and we'll just look at the 30 and the 150. So I have cos 30, which has a value. If I look at my log tables, I can get a value for that very, very quickly, which is root 3 over 2. And a lot of the time we're using the angles 30, 60, 45 here. Sometimes we'll use other angles, but most of the time you're reading them directly from the log tables. So cos 30 is root 3 over 2. Cos 150, okay, we're now saying is the same as cos 30. Kind of. But cos 30 is in the first quadrant. That's in Q1. Cos 150 is in the second quadrant. So that's Q2. Therefore, it's the same as cos 30, but it has to be negative because it's in the second quadrant. Okay, so it has the same numerical value, but it's minus root 3 over 2. Okay, if I look, for example, at, let's say I want to get sine of 330 degrees. Okay, so first of all, 330 degrees, if I go up here, is in this section. Okay, it's here. Okay, so all the way around, if I rub off this just to give us, I can't. Okay, if I look at, I'll highlight it. If I look from here all the way to here, that is 300 degrees. 330 degrees, sorry. Okay. Remember, your reference angle always has to go to the horizontal. Okay, so my reference angle in this case is this one. Okay, so 330. So this angle here is 30. Okay, now, so sine 330 is the same as sine 30. Okay, but because it's in the fourth quadrant, it means it has to be negative. Okay, so if I look at the value on my log tables for sine 30, okay, sine 30 on the log tables is a half, okay, from that table. Then this value is minus 1 over 2, okay, because it's minus a half. Okay, this time let's look at the angle equal to 225. Okay, so the angle 225 is down here. So remember, going all the way back to 0, that is 225. Okay, I'm actually going to rub this out, but you can take it down. Okay, now it's down here, it's in the third quadrant. My reference angle is here. Okay, so if I have cos of 225, okay, I've got to look at, first of all, is cos positive or negative in the third quadrant? So if I remember sex and the city, the only thing positive in the third quadrant is tan, so cos must be negative. So cos 225 is equal to minus cos of the reference angle. Okay, and the reference angle, because I know that point there is 180, so from there to there is 225 minus 180. Okay, so it's an additional 45 degrees. Okay, so cos of 225 is equal to minus cos of 45. Again, if you look at your log tables, that will give you a value of minus 1 over root 2. If I was to look for tan of 225, okay, in this case, tan is positive in the third quadrant. Okay, so tan of 225 is actually just equal to tan of 45. Okay, they hold the same value. For every angle in the unit circle, there are two values of that angle. Okay, because there are two quadrants that will be positive and two quadrants that will be negative. Okay, and what the unit circle does is it really just repeats the values of 0 to 90 across the unit circle. So tan of 45 is equal to 1. If I was to look here, for example, at the angle 210, for example, okay, so actually 210 is in that same quadrant. Let's go for let's look at the angle 300. Okay, the angle 300 is in the fourth quadrant, so it's down here. Okay, let's rub this one off. Okay, it's in the fourth quadrant. Its reference angle, remember, always goes to the horizontal. It's always to this line here. Always, always, always. So if this is 300 degrees to here, and the full way around is 360, well, this angle here has to be 60 degrees. Okay, so if I'm looking for sine of 300, okay, the very first thing I have to think of is, well, in the fourth quadrant, so this is Q4, is sine positive or negative? So again, if you think sex and the city, okay, the only thing that's positive in the fourth quadrant is cos, so sine has to be negative in the fourth quadrant. So sine of 300 is equal to minus sine of 60. Okay, and if I go to the log tables to see 60, it'll be minus root 3 over 2. Okay, so on the log tables you were just looking up sine 60. Okay, and you get root 3 over 2. The minus sign, that's not great actually, the minus sign is separate. Okay, if I want to look here at cos, $300. Okay, in the fourth quadrant, cos is positive. Okay, so cos of 300 is the same as cos 60. Okay, so cos of 60 is 1/2. Okay, if I want to look at tan 300, okay, that's going to be the same as tan 60, because it's always going to be the same as the reference angle, but tan is negative in the fourth quadrant. Okay, so it's negative in the fourth quadrant, so tan 60 is root 3, but because it's in the fourth quadrant, it's minus root 3. Okay, this also holds for angles much greater than 360 degrees. Okay, so if I account for an angle, say for example, let's say my angle is 510. Okay, now 510 is equal to 1 full rotation, okay, plus an additional 150 degrees. So 1 full rotation is 360 plus another 150. Okay, so technically I go around the circle the whole time and then I end up over here. Okay, 150 degrees. Okay, and again, I'm looking at my reference angle. So there's a huge number of angles that equal every number between 0 and 90. Okay, they're repeated so many times along the unit circle. And then this reference angle is going to be 30, because if this is 150, then 150 to 180 is 30. Okay, which means if I want cos of 510 degrees, it's going to be the same as cos 30 degrees, but remember it's in the second quadrant, so cos is negative, and minus cos of 30 degrees is minus root 3 over 2. Okay, and this is all based on that table in your log tables on page 13, the same page as the unit circle. Okay. Okay, now let's look at the unit circle with radians. Okay, so in this case, okay, now instead of 0 degrees, 90 degrees, 180 degrees, we know that in radians, pi is equal to 180 degrees. Okay, so I have 0 degrees, 90 is pi over 2, 180 is pi, and 270 is 3 pi over 2, because you have to be able to read this in both radians and degrees. Now, you can always change these values into degrees. Okay, so you can always change into degrees and then change back to radians afterwards if you find it easier to work in degrees. Okay, but let's have a quick look at the unit circle with regards to radians. Okay, so first of all, let's say I was looking for a value where the angle was 4 pi. Okay, now 4 pi is 2 full rotations. So if 2 pi is 1 full rotation, well then 4 pi is equal to 360 degrees, which is also equal to 0 degrees. If I was looking for an angle of let's say I was looking for an angle of 5 pi over 2. Okay, now first of all, that's more than 2 pi. Okay, so the first thing I have to do here is I've got to take 2 pi out of it, because 2 pi is a full rotation. So I want to find out what do I have left after that. Now I can simply put 5 over 2 pi onto my calculator and subtract 2 pi, or I can simply just take the pi's out of it. Okay, So subtract, and you can do this on your calculator, subtract 2 pi, okay? And you'll get, if you're doing this on your calculator, you'll get a half pi, which is the same as pi over 2, okay? Which is the same as 90 degrees, okay? And if I was looking for cos of pi over 2, okay, I can simply go to my log tables, okay? Cos of pi over 2 is 0. If I was looking for sine of pi over 2, okay, sine, go to pi over 2, down to the value for sine, will give me 1. Okay, now let's say we have a more complicated angle. Let's say my angle is 5 over 6 pi. Okay, now 5 over 6 is not quite 1 pi. Okay, 5 over 6 is close to 1, but it's not 1. So I know it's in this quadrant. Okay, so let's say I was looking for cos 5 over 6 pi. Okay, the first thing I have to do is I need to know what's this reference angle. Okay, and the same as the last time, I'm looking for the difference between, so if that's 5 over 6 pi, I'm looking for the difference between that and that. Okay, so to get up to 1 pi, okay, this is going to be the same as cos of 1 over 6 pi. Okay, now I could simply just say pi minus 5 over 6 pi. Now remember, you can always turn these into degrees and work solely with degrees, but I want to give you an overview on working with radians. Okay, so we have cos 1 over 6 pi. Now remember, you have to think cos in this section is negative. So cos of 5 over 6 pi is actually the same as minus, okay, because it's in the second quadrant. Okay, so then I go up here, 1 over 6 pi, that's the same as cos pi over 6. Go to pi over 6, go to cos, and that is minus root 3 over 2. Okay, let's look at one more here. Let's say I have sine of 7 pi over 4. Okay, so I got to think, where does 7 pi over 4 lie? It's definitely greater than pi. Okay, 3 over 2 would be 1.5. So 7 over 4 is definitely greater than 1.5. So it lies in here. Okay, so it lies somewhere in here. Okay, 7 pi over 4. Alright, remember, a reference angle always goes back to the horizontal. So I'm always looking at here for my reference angle. Okay, which is the difference between 2 pi and 7 pi over 4. So 2 pi minus 7 pi over 4. Okay, you'll actually get 2 pi, that is 1 over 4 pi, or pi over 4, which is the same. So going back down here to sine, okay, we have sine 7 pi over 4 is the same as sine pi over 4, but if we're thinking sex and the city, sine has to be negative because the only thing positive is cos, so it's minus sine pi over 4. So going up to pi over 4, going down to the sine value, minus 1 over root 2. Okay, and it's exactly the same. So I always have two values for every angle from 0 to 90. There are two values of that between 0 and 360. For every single angle possible, if I go to 400 to 500 to 1000, I just keep rotating around and around and around the circle, but I'll always get back to the same one of two angles.